Hi guys, it's Mrs. DeLoss again. We are looking at equilateral triangles. So it says, how do we construct an equilateral triangle that is not inscribed in a circle? We'll talk about being inscribed in a circle in a previous skill, but that's not this skill. So it says, list two properties an equilateral triangle holds. Well, one, all sides are congruent or equal in length. And number two, if all the sides are congruent, then all the angles are congruent. Or in other words, equal in measure. We change the word from length to measure when we're talking about angles because you don't have a length of an angle, you have the measure of an angle. So keep that in mind. It says, which of these two properties can be controlled by the use of a compass when constructing the equilateral triangle? And how would you control it? So it's really hard to construct angles without using the protractor, and we're not going to use the protractor in this course. So the sides, remember, when you open up from the center and you stretch your radius out, what you're doing is creating sides. So we can control congruent sides, and we would do this just by keeping the same radius. So what I'm going to have you do is just pause your video, and I want you to try using a compass and a straight edge to construct your equilateral triangle whose sides are the length of CD. So every single side of your equilateral triangle needs to be the length of CD. And remember, if you are struggling to recall what an equilateral triangle looks like, all the sides are equal or congruent. So take a second to just try something on this little image here. Okay? Pause your video. Now we're going to try this together. So we have that same segment CD, and I want all the sides to be equal to the length of CD. So I'm going to put my center on C, and my radius opened up all the way to D. Okay? I'm going to dip down just a little bit, swing a little below, and then swing way up above. Giant. Okay? From here, I'm going to keep the same radius, but flip my compass or my paper upside down so that I can now put the center on D. The radius should now be touching C. If it's not touching C, then your radius was not opened properly in the first place. Swing a little below and way up above. So it looks like we've got this curvy triangle going on, but we don't love curvy triangles. I'm going to call this point E. It didn't tell us what to call it, but you can call it whatever you'd like if it doesn't designate a letter for it. Curvy triangles are not okay. You have to make that final step of connecting from C to E and from D to E. So now I know that every side of this triangle, CED, has the length of CD, and they're all congruent to one another. So if we take a second to flip our paper over, it says write a clear set of steps for the construction of an equilateral triangle. It says start with center on one endpoint. In this case, we started on C. And the radius on the other endpoint, D. Swing slightly below and way above. Switch, put your center on D and your radius on C. Swing the arc slightly below and way above again. Connect both C and D to the point of intersection of the arcs. We happen to call it B on the previous, or on this set, we called it E in our own triangle. To make triangle, and again for us, it was C, E, D. Like I said, you could have called it B, you could have called it A or Q, or G for Griffin because that was my maiden name. Whatever you wanted to call it, you could have called it that. Okay, because they didn't tell us what to call it. So now that we have the steps listed out, we're going to look at example number 2. It says construct an equilateral triangle RST. So they are telling us that we have to have those 3 letters such that the sides of the triangle with a vertex at R, the length of the side of the triangle must be the same as the length of AC of the rectangle below. So I'm going to focus solely on AC. So the first thing I have to do is measure it. So what we're going to do is put our center on A and our radius on C. To show that we've measured, we have to actually swing a little baby arc. Okay? From here, we're going to put our center on R. I'm going to dip slightly down, way up above. And then this is our new point. I'm not going all the way to where that arrow is, right? This is our new point, so we're going to call this one S. From here, I put it on S, keep the same exact radius, because remember we want all the sides to be equal. Equal radius means equal sides. And swing slightly below, way up above, and connect. This will be T. Curvy triangles are not cool. They're not something that we love, so we have to connect them. And now we have triangle RST with all side lengths equal to the length of AC from the rectangle they gave us. Take a second to write a little summary. What did you learn? How do you make an equilateral triangle? And then we will come back together next class to practice.